Can everyone hear me? Perfect. All right, welcome to United Astronomy Clubs of New Jersey. We are once again live on site. It's actually a fairly nice, clear night. We have a good turnout. We just look like we have a couple people just filing in. So, a couple things to note. Uh, we are a nonprofit, so everything you guys have done to support us, whether it be coming in, signing in, or viewing us online, has all helped keeping us out there and relevant. Um, that being said, you can check us out on our website, uacnj.org. That's where you will find a list of all our telescopes that we have open, all of our member clubs. So if you are local to the area, you can see a list of other astronomy clubs that are part of us that we suggest you check out if you are local to them, because the best way to start into astronomy is actually getting to know your local team. That being said, you can also look at our list of ongoing programs. So you will see, apparently, I lost the train of thought. So we're going to move on from that thought. You can also check us out on our social media. We have Facebook, Instagram, Twitter, and also a Discord channel, which I'm hoping to get people posting photos of their astrophotography like he does tonight. That being said, we are live streaming this to our YouTube channel. So if you ever can't make it here, you can always check us out live there. Or if you can't view us live, you can go back and watch our videos after the fact and comment and like and subscribe there. Right. So it looks like most of us are settled in here. So for the people here, if you do need to use the restroom, that is the porta potty to my right, your left. We do have a museum and gift shop area that you can check out after the fact. All the proceeds go to keeping our lights on and allows us to offer free public programs. We are aware that there are some, I've just been made aware of, there are some issues with our live stream dropping some frames. But it is an internet problem and unfortunately not in our control. My team in the background just wanted me to say. For the people here again, when we go to leave, we do use our headlights because we like not running people over. It hurts. Trust me on this, we do not test this. That being said, if you do have a flashlight, do try and keep that pointed down towards the ground because we don't need to unnecessarily blind people. And with that, we're going to get into tonight's program, which is Mike's journey into deep space astrophotography. Mike is a chemistry major from Seton Hall University and has worked in the pharmaceutical industry and later was in technical sales of laboratory instrumentation, specifically spectroscopy products. Photography has been a lifelong hobby, from developing black and white film in high school to digital SLRs. Astronomy had been an interest for many years, and after retiring, astrophotography has taken up much of his time, especially since he joined USANJ 2 years ago. And with that, we're going to get into tonight's program.
Thank you. Okay. What happened? There it goes. Okay. Good. Thank you. Okay. As you heard, my journey into deep space astrophotography, or I could have called it How to Do Deep Space Astrophotography. Can you hear back there? Too low? I'll try yelling. Is that better? Okay. First, what I want to say is I have an agenda of what I want to cover. And when my wife heard the talk, she thought it was too technical. So I'm going to try and keep it as, so everybody understands. There's a lot of children. Um, I want to do some definitions so when you hear certain terms, you know what they mean. Uh, I'm going to talk about the gear I use to do deep space astrophotography. I want to talk a little bit about the procedures, the step-by-step objects and procedures that have to be done before you get a photo, and that could be extensive. And then I'll talk a little bit about the objects that you want to photograph, or where they are, how far away, and some examples. Especially at the end, I have a lot of examples of photos I've taken right here, because I've been involved with astrophotography about 3 years now, but only in the last 2 years have I been doing tracking astrophotography, which means not using a solid non-moving tripod, but using a mount that tracks the stars. Now, I hope you could see this photo I have up here. This is called the North American Nebula. It's right there, and you can kind of see the Gulf of Mexico. It's this shape, and it's a nebula, and a nebula is a gas cloud. The names are made up by astronomers, and oftentimes it's because of the way they look. Next to it, you see a beak, and that's the Pelican Nebula. And then I want you to know what a good photo looks like. This is a decent photo, and the reason is if I look in the corners, I want to see if the stars are round, because if I didn't do a good job taking this photo, the stars won't be round. They're going to be oval shaped. Maybe there was a gust of wind. And whenever you do deep space astrophotography, you're always taking long exposures. I put this one up first because this was earlier in my career as an astrophotographer. This one was taken with my Canon 80D camera. It's a digital SLR, and I just used a 300 millimeter f4 lens, a telephoto lens. So keep that in mind. A lot of these objects are not tiny, they're rather big. The other thing I want to point out in this photo is the colors. Look at this star right here. You see how blue it is? Well, that's an indication, and this one here is reddish yellow. That's an indication you didn't over process it. You got some color in the stars, and later we'll see what that means. Okay, first definition, what is deep space? And the simple explanation is it's all the objects in space beyond the solar system. And I guess everybody here knows what the solar system is, right? It's the planets, the sun, and all the moons. Now, when you look at deep space, the first thing you should realize is you're looking at objects millions of miles away, and oftentimes they're very dim. So there's a light measure. You can't hear? That's better? Okay. Um, Light travels at 186,000 miles a second. So you could imagine how far 1 light year is. And you're going to see some photos here of some galaxies that are over 25 million light years away. That's really deep space. The objects you observed are the way they appeared because it took the light so long to get here. It's the way the object looked thousands, millions of years ago. They could have blown up yesterday and we wouldn't know about it for another million years because we have to wait for the light to reach us. So that gives you an idea of scales that you're talking about. And the closest objects that we see and still consider deep space are things in the Milky Way galaxy. And of course, we live in the Milky Way galaxy. And I'll show you some pictures. And most are faint objects, but some are very large. You have to use you can't use too big a telescope because you can't see the whole object, especially when you talk about gas clouds, the nebulae. Oh, and by the way, this is one of those galaxies that's 25 million light years away. This is called the Pinwheel Galaxy, M101. And that was taken here also. Now, for the chemists in the room, we have a definition sort of what light is. And my point here is everything we see has to go through the atmosphere, and the atmosphere is incredibly good at protecting us. It absorbs. You can see the absorbances are very high in the gamma rays, the X-rays, which are deadly to us. We get some radio waves coming through. Those aren't blocked. And then, of course, we have the visible light. And the visible light, I want to say, science says it's a wave. And you know, when you look at the colors of the rainbow, those are different wavelengths of light. But the other thing I want you to remember is it's also a particle, and a particle of energy. And those particles are called photons, because later you'll hear me referring to how do you get a good photo. You collect as many photons as you can from these objects, and we'll talk about that. Now, remember I told you there's a difference when you look at stars if you have a good photo? Oh, sure. My head was cut off on the video. I like it that way. Okay, getting back to the color of stars. Astronomers have a lot of information, and you saw the North American nebula, and you saw the blue star and a yellow-red star. Well, guess what? When stars are, and by the way, nebula, these gas clouds are where the stars are formed. The gases condense and form stars. And the stars, when they're first formed, it's all the hydrogen. They're very rich in hydrogen, so they're doing nuclear fusion, and they're combining, and they're very hot stars. And they actually look a little bit blue. And Rigel is one of the big stars. It's a bluish tint. So if you look up in the sky tonight and you see Rigel, you see a little blue if you have good eyes. That means it's a hot star at 12,000 degrees centigrade. Our sun is a medium 5,500 centigrade yellow. And if you look at Orion in the winter, the shoulder star of Orion is Betelgeuse. And Betelgeuse is a big red dwarf. It's a big red star. Because as stars get older, they use up a lot of the hydrogen, so they don't burn as hot. So I thought that was interesting because younger stars are bluer, and so when you see pictures I'm going to show you later of nebulae, you'll see blue stars here and there because they were formed from the gas cloud itself. Now, what do you what items to consider to get a good photo, astrophoto? And here's that word photon, a packet of energy of light. The number of photons of light collected by your camera sensor, that's it. Nothing else really matters. If you can maximize that, you'll get a better photo. The more photons you have, the better your photo is. And to maximize your photons of light, the first thing is the aperture. So the bigger the telescope, the bigger the opening, the aperture is, the lenses, it collects more light. The second really important factor in getting good photos is the exposure used. You know, if you open up the lens and you leave it open for a second, you get a lot more light coming in than 1/10 of a second. And in astrophotography, we often talk in terms of minutes. And of course, there's different types of cameras, different sensors. Some are more sensitive than others. And The other thing I want to mention is elevation of your target. In astrophotography, because you have the atmosphere, unlike the Hubble, the Webb Space Telescope, where they don't have it, you get interference, you get particles, you get diffusion of light before you catch it. So the higher up you could point your telescope, the better for the pictures. If you have a choice between straight up and on the horizon, the one on the horizon is going to give you problems because you'll get interference or noise, we call it. Yes. The what?
Okay,
Scalino?
we will be having a question and answer session at the
I
end,
don't think I could
um,
answer that.
so that you guys will be able to use the mic to ask your questions, so our online audience would also be able to hear. And we just ask that you hold questions like that to the end, please.
Yeah, that's a tough question. So, anyway, so the elevation of the target is important, and sight darkness. Uh, I live in Parsippany. I have to come here to get photos because the difference is very large. And to show you what it is, astronomers use something called a Bortle scale. And a Bortle scale is a way for astronomers to rate how much light pollution is in the sky. And there are maps on the internet for where you live to tell you. And if you're in an urban city environment, you're going to be up here 8, 9, even 10. A lot of light pollution. You see how bright that is. And there's no way you're going to see a lot of stars and the Milky Way. This site here, United Astronomy Clubs of New Jersey site, is a Bartle 4. So it's pretty good. And you can see if you have a good clear night, you can actually see the Milky Way from here. But it does need to be a clear night. Now, using filters, some people think that's a magic bullet. But filters, what they do is these filters, they absorb certain wavelengths of light so that the certain wavelengths of light don't come through. The lights from the wavelengths of light from stars, from nebulae, they come through, and the net effect is it darkens the background. And here's a photo taken under the same conditions, 90 seconds, in a polluted area, Bortle 8, and this one has a filter on it. And you can see, because the background is so much darker, you're able to do a longer exposure and therefore get more photons and get better pictures. But if you have a choice, always go with a lower number. By the way, I don't know what the lowest number in New Jersey is. It's probably in the 3, 4 area. Yes? Is it? Thank you. I know Maine has a place where that has a 2. And here's an example of the difference in photography. This is the Great Nebula of Orion. This is one you can actually see with your eye if you know where to look. And on the left, it was taken from the Parsippany area. There's some other differences, and this one was taken from here. So allowing more photons of light to get in, and which allows you to expose it longer, means you get a lot more luminosity details compared to one in a polluted area. Now, the other important thing that you have to understand is you get star trails if you're not careful. If you set up a stationary tripod and use a DSLR and open up the lens, you'll get star trails. Now, does anybody know what direction the camera is pointed to in this photo I got off the internet? Yes. What? Exactly. It's pointed north because there's only one place in all of the northern hemisphere, actually anywhere in the world, and there's only one star that doesn't have a star trail, and that's Polaris, the North Star. And that's really important because when you do astrophotography, one of the important things you have to do is align your mount to the Polaris. And that alignment has to be almost perfect. The better it is, the better your tracking will be. Remember, a mount will move with the stars. And I put on here, the stars aren't moving, you are. It's the rotation of the Earth that causes the stars to appear to be moving. And now, wouldn't it be nice if you could calculate how long you can expose your camera and not get star trails? Well, guess what? Somebody did that. And it's called the 500 rule right here. Oh, I'm sorry. What happened? Uh, there it is. I didn't like that slide anyway. This is where I actually started doing astrophotography, and it's called untracked. It's called the simplest way of doing astrophotography. And you set up a tripod, you put your camera on it, you open up the lens to the biggest aperture you can, f1.8, f2. You put a timer on it, and you hit the go button. And if you do the right exposure, if you have a wide angle lens, you can use a longer exposure, and that's how you find it. A regular lens on a SLR camera might be 50 millimeters, right? Well, if you put 500 divided by the focal length of the lens, that's what the 50 millimeters is, you end up with 10. So you could use a 50 millimeter lens, put it on a stable tripod, aim it at the stars, and get the Milky Way galaxy, for example, without getting star trails. If you go longer, you'll start to see elongated stars. If you go 30 seconds, you'll have long arches. The first photo you saw was the North American Nebula, and I said it was a 300 millimeter lens I used to get that one. Well, guess what? If you put this in here, in the formula, that's 1.6 seconds. So it's rather limited, the fixed tripod, because that exposure was 5 minutes. So much longer than 1.6 seconds. And I didn't get star trails because I have a mount that follows the stars. Fixed tripods are good for things like constellations to get star trails, the moon, of course, comets and meteors. And here's a photo in a Bortle 2 class area, but I didn't know New Jersey had one, so I went up to, we were on vacation in Acadia National Park in Maine. And I went out on the rocks. Of course, you have to scout it ahead of time to know where to go, which direction the Milky Way is going to be. And there, the night, there's no lights around. You could see it with your eyes. And I used a 15-second exposure, and this was a wide-angle lens. And I captured the Milky Way galaxy. That's what we live in. Now, I did cheat because here you see the rocks and the coast. That was taken during the day, and I merged it because if it was taken at night, this would be all black. So keep that in mind. You know, you're going to get the Milky Way, you're not going to get this part. The other things you can do with this type of astrophotography is take pictures of the moon, as well as some planets. And these are heavily cropped. In other words, the moon was much smaller. And I took a picture of Jupiter, and it's hard for people to see, but you'll have to trust me. I could see 4 little small moons of Jupiter, right? 3 here and 1 here. But that's, you know, from here with my 600 millimeter lens. But the moon is a great target, and you can, if you take it when it's a quarter illuminated, not a full moon, that gives you the best shadows along the line here. So you see the craters real nicely. So that's something anyone can do. Now we get, oops, let me go back for a second. Now we get into the serious stuff, the deep space stuff. Here's Andromeda Galaxy. And I'm not going to lie to you, this was not my first shot. This was my first shot. And when I got that, I was using a small tracking mount with my camera and my 300 millimeter lens. I did I don't even remember, it might have been a 30-second exposure, but boy, was I happy when I got this photo, because I couldn't see Andromeda, but when I developed it and I saw it, I could see it wasn't a star, it was a cloud, and there was a little bit of a dust lanes in it. So I was really, of all the photos, that was the most exciting for me when I started. As you get better, you take longer exposures, you work it up better, you can get Andromeda Galaxy looking like this. And if you come to a darker site, like here, you can get a photo like this of Andromeda Galaxy. And now you've got details, some color. And by the way, this and this, those are other galaxies. Andromeda is, I'll show you a more detailed photo later, and we'll talk about it some more. This is my first rig that I use. It's a very basic Ioptron Spy Guider Pro, and I put my Canon camera on it. It has a polar alignment. You look through here to align Polaris. You have to align Polaris no matter what you do. A counterweight to balance you're always balancing the camera, because you don't want the motor and the gears that track it, you don't want them working very hard, because you want them to be accurate. And if you balance it, it's very easy for it to move it, and you get good guiding. That's the key. And there's the photo you can get with just a small Ioptron guider. And again, that's Andromeda Galaxy. This is the closest galaxy to us, right? It's only 2.5 million light years away. But isn't it, I'm always amazed when I look at a photo like this, because I said, I can't believe I took that photo. And I was reading something on the internet. This is an aside. This is not part of my presentation. I was reading something on the internet that said that just 20 years ago, the type of photos amateur astronomers are getting, you had to be a professional astronomer to get that type of photo. Just 20 years ago. The technology has improved, the camera technology, the digital controls, the guiding. So it is an amazing thing to be able to get photos like this. The gear needed, by far the most important piece of equipment, and the one you should spend the most money on, those of you who are thinking about getting into it, is the tracking equatorial mount. Because that, if it's not a good one and you put too much weight on it, if it's not a good one, it won't have the right gears to give you very accurate guiding. So that's very important. The telescope, that's important, but you have to size it according to what you want to photograph. If you want to photograph Andromeda Galaxy, you get a really powerful 8-inch reflector, you're going to get like 1/4 of it. Andromeda Galaxy, if it was brighter, it's very dim, but if it was brighter and it was up in the sky, if it was next to the full moon, it would be 6 times bigger. And that's amazing. So you need to use something like a 300 millimeter lens, 150 millimeter to get this photo. Power source, and then there's other things as you get more advanced you have to do, but we're not going to go into that today. That'll be in the advanced course. Anyway, one thing I learned as I got more into astrophotography is how important focus is. With a digital SLR, you aim it, you put your finger on the trigger, and it auto focuses, and you get a nice photo. Not so with astrophotography. Whether you use a telescope or a digital SLR, focus is critical. And the way to do it is to turn the focus and make the stars as small as possible. When you get them real small, you've got a good focus. Well, how do you know you've got it the smallest it'll go? And so there's something called a Bahtinov mask. You put this over the front of your telescope or lens, and it forms an interference pattern. This is made out of plastic, and I took a picture of my computer, and that's the pattern you get on your computer. when you look at, you actually have to take a picture of the star, and that's what comes back. And it's an X right here. And you see this line here? This line moves up and down depending on whether you're focused or not. When you finally get perfect focus, it'll look just like this. All three of them will meet in the center. So that's something you should be aware of if you get into astrophotography. Now, to make these photos, you're talking about very minute changes that could have a big effect on your photos. So the first thing you do, and I did it a little while ago in the back, I balanced my tracking mount. So I set up my tripod, I put the mount on it, and balancing means that if you move it to any position, it'll just stay there. One side won't be heavier than the other side. So you do the right ascension balance, and then you do the declination balance. Once it's balanced, you do your polar alignment. Very important. You have to usually wait till it gets dark, because you can't see the Polaris like right now. So you have to wait till it gets dark, and then I do it manually. I look through the mount. There's a special polar scope, and you use adjustment screws to make sure that Polaris is exactly where it should be. The focusing, I mentioned to you, there's a free software, PhD2, for guiding. And let me just say right now what guiding is. Guiding is, no matter how good a mount you buy, it can't track the stars precisely enough if you use a long exposure. Remember, to get good pictures, you want a lot of photons, you want long exposures. So what you have to do is you put another telescope, a small one, on top of your big telescope with another camera and software controlling it. It's called the guide scope and guide camera. And what it does is it locks in on one star automatically, and it just monitors the star. As soon as the mount drifts a little bit, the star drifts, and it sends a signal to your mount to correct it. So now it's constantly correcting your mount, so you're tracking the stars real accurately, and you get nice exposures even after 5 or 10 minutes. But that's important. And it's something you could start off doing 1 minute, 2 minute exposures and not need to guide, but when you go longer exposures, you need to guide. And of course, good seeing conditions. I'm not going to go into some of the other things, but I did want to point out that you don't have to spend a lot of money on software to do this. And that was an eye-opener for me. This is what I use, Stellarium. It shows you where the stars are. It sends your mount to the right location, and it's free. Astrophotography tool, that's the main software that controls the camera. It does plate solving and all kinds of advanced features. It takes the pictures, and astrophotography tool is free also. PhD2, that's the guiding software you really need if you're guiding, and that's free. You download these off the internet. Deep Sky Stacker, we haven't talked about working up your photos, but if you do deep space astrophotography, you're always working up your photos. Post-processing is absolutely necessary, and Deep Sky Stacker is free, and it does a big portion of that. Surreal is also free. Photoshop you have to buy if you're going to use it. But these are the software packages I use. Here's my first guided rig. That's my HEQ5 mount. That's a 600 mil lens. My DSLR camera, and there's my guide telescope with a small camera behind it. And I used it on a bracket. So I did some guiding even when I was doing my telephoto lens. And here's my current setup. And those of you that are interested, you could take a close look, because I have this exact setup in the back. And again, I've got a telescope, a guide scope. This red object is a guide camera. And I'm not using a DSLR, I'm using an Astro camera. they're more sensitive. They collect more photons of light. Um, there's a whole slew of other things, but for now, I didn't put in all the cables and computer and tables and all the accessory stuff you need. There is a website if you're getting into astrophotography that gives you a lot of calculations, including the big thing to remember is because you can really get different focal length telescopes, very large ones and very small ones. It's important to know that you're using a good camera to get a good photo. You have to match the two. And this site makes it very easy to do. And when it's set up, that's what the pad back there looks like, where a lot of us astrophotographers set up. And that's my gear. That's Samir with his stuff. I have one of the smaller telescopes. Some people have beautiful ones. I gotta make sure I get good pictures before I move on. This procedure, I'm gonna summarize it quickly. Right now, what I did before you got here is I took my tripod, I set it up, and I made sure it was pointed north towards Polaris. I know where Polaris is going to come up here. I next leveled the tripod. I have a little level. I made sure it's level. That's critical because later you're going to do the star alignment, the Polaris, and you need that. I put on the telescope, the guide scope, the two cameras, counterweights. I didn't use a dew heater this time. I mounted them all with all the cables, and I did all that so I could balance everything. And I mentioned balance a few times because it is important to get good pictures. And so I have it somewhat balanced, and I'm waiting for it to get dark because hopefully tonight, if it's clear, I'm going to do some astrophotography. So once the sky is dark, you do the polar alignment. Next, I use stellarium, and I find a bright star. This is my procedure. So I slew over to the bright star, I center it, I put the Batinov mask on, and I focus. That's so important that I do that before I do anything else, after I've aligned it with the Polaris. Once I've got it focused, it's a simple procedure from there. I just tell it I want my computer, I tell my computer that controls the mount that I want to go to Andromeda. And it slews over to Andromeda. I made sure it's centered by taking a test exposure. Then I start my guiding equipment. Remember, I have a guide scope and a camera. I start that. I do a quick calibration, only 4 or 5 minutes. And it's set to go, and it starts guiding, and it'll show you upper and lower control limits as it's guiding, sending signals to your mount to keep your target right on target. And after that, I actually start taking pictures. And so that procedure, by the way, sometimes takes me up to an hour. By the time you unload everything, get it set up, so you have to be devoted to do this. After collecting the pictures, you collect other things like dark frames. You put the cover on the telescope and you shoot black frames. Then I have a special light to get flats. These are used when you're working up the photographs to make corrections. And then when I'm all done, I pack up, I go home, and then I use Deep Sky Stacker and other software to finally come out with a final picture. And before I do that, let me just say that stacking is why astrophotography is possible, because what you're doing is you're shooting a very dim object, and you're taking perhaps 30 photos, each one 5 minutes long. And the reason you're taking so many of the same thing is so you could do this. By using Deep Sky Stacker, when you stack everything, you improve your signal to noise. And I could have called this talk Improving Your Signal to Noise in Astronomy, because that's what it's all about. Everything you do is to improve the signal to noise, the position of the dark site. That's all to improve the signal to noise, and that's a very powerful tool that every astrophotographer uses. Deep space images. What I want to say here is, when you do multiple exposures, those of you that have done this before or are astronomers, you know that if I take 16 exposures, 5 minutes each, and I stack them, it's the square root of the number of exposures that tells you how much improvement you get in your signal. So 16, the square root of 16 is 4. So you get 4 times better signal than if you just took a single photo. So that's an interesting fact. And now I'm going to show you the result of all that. And there it is. That's Andromeda. That's probably my best photo. And you can see some details here. This was 2 hours exposure. I actually used my Canon 6D camera. By the way, you see Messier 31 or M31? A lot of my pictures will have numbers like M31, M101. Charles Messier was a French astronomer in the 1700s, and he was tracking all different comets with a small telescope, and he kept getting fuzzy objects all over the place, so he started cataloging them, and now he's famous for his Messier catalog of 110 objects, and they're galaxies and nebulae for the most part, and star clusters. What's nice about this is you could see the dark lanes, and you could clearly see the other 2 galaxies, and it's 2.537 million light years from here. And it's a huge galaxy. This galaxy has 1 trillion stars, which is much bigger than the Milky Way, the galaxy we're in. And you'll see some other galaxies that are smaller. Now, this is the opposite. This is a small object. So remember, I told you Andromeda is big. So that's why I use my 6D camera, because it allows me to take bigger objects. I have another camera that has a very tiny sensor, so you get a much greater effective focal length. And I use that one to take the Horsehead Nebula. And that's near one of the stars on the belt of Orion. And you can see it's a dark nebula, and you can see a blue nebula here. This is a reflectance nebula, and this is a dark nebula. The only reason you see the Horse's Head, I hope you can see that, is because the red emission nebula is in the back. So there's 3 different nebula, and the dark one is only visible because the one is illuminating it from the back. And remember, this is where stars are born. That's why some of these stars have a bluish tint to them. They're hot. They're new stars. This photo is interesting for many reasons. It shows that with one telescope, by using different cameras, I can get a very small galaxy. This is the Triangulum galaxy, and it's just a different angle. And here's the Andromeda, and here's my Milky Way. So I used 3 different cameras with a wide-angle lens, and these 2, I used 805 millimeter telescope, 6D camera, 183 camera, and that's the difference. The other thing you keep in mind when you do astrophotography is framing objects. And by using different cameras, you get different looks. Here is the Cocoon Nebula. That's the name of it. And you see the dark trail in it. You see some of the blue stars that were formed. Again, it's a gas cloud, so it's forming stars. And it's a nice photo. But I like the photo I took of the Cocoon Nebula with the same telescope, but with a different camera. And the reason I like this one is it amazes me how many stars are in the photo. Just this is what space is like. And what you're looking at is everything in the Milky Way galaxy, because we're not looking at different galaxies. This is all the Milky Way with the stars. And you do see some of the blue color in the stars. Uh, so keep that in mind. Framing is important, how you shoot. So deep space examples, how we doing? We're doing good. Galaxies, nebula, star clusters, and Milky Way. That's really what you could take. So here's some I took from this site. First, let's talk about Orion a little bit. Orion is famous in the winter sky. Everybody could pick out the 3 belt stars. The Horsehead Nebula I showed you was right there, right around this first star. And the Orion, the Great Orion Nebula is right there. And on a clear night, you could see a little color. You could tell it's not a star. Most people think it's a star. This is called the Sword of Orion. And there's Betelgeuse in the shoulder, right? That big red star. Here's a picture I took by the way, the last photo was from the internet. I didn't take that. This one I took from a Parsippany area, and you can see the Sword of Orion is really, the center star is the actual Great Orion Nebula. And if you blow it up, you can see that you get a lot more detail, luminosity, and that's the most famous nebula, and it's every beginner loves to shoot it because it's the most dramatic one. And when you get to a dark site and you take longer exposures with a telescope, you can get tremendous details in the gas cloud, the stars, and you even get a second nebula. It's called the Running Man Nebula, the red. You could kind of see a head, 2 arms, and legs. Astronomers name it for what they see. And again, to get this photo, I actually shot it over 3 different nights. It was in February 20th, 21st, and the 26th this year. And I put all the frames together, worked them up, and I got this photo. It's about 1,300 light years from Earth. So it's the closest star-forming nebula to Earth, and it's the largest and most dramatic. Here's now, I own a Subaru, and you know the logo on a Subaru? That's the Pleiades star cluster. That's what it represents, the stars. And here it is. This is my photo of it from here, and you could see that you do have nice color in the stars, and you also get a lot of luminosity. This was about I think it was a 3-minute exposure. It was 1 hour, so I did 2 3-minute exposures for a total of 1 hour. And you could see the luminosity, and these are actually nebulae, and it's a gas cloud that the stars are actually passing through. That's why you have that effect. It's getting harder to see. Here's our favorite, the triangulum. I want to point out all the details in the blue stars, different colors. This one is 2,700 light years, 2,700 million light years away, and it's just the second closest galaxy to us, and together I wanted to show you one that's further away. I took this one recently in April, over 2 days, and this is the Whirlpool Galaxy. This is, if you look at the Big Dipper, the last star of the Big Dipper in the handle, it's right in that area. And so it's kind of easy to find, but even if you look through a powerful telescope, you don't get this type of detail and luminosity and the swirls and the color. And it's known as Messier 51A, and it's 23.16 million light years away. And this is a favor. I cropped this a little bit because my telescope isn't big enough to make it bigger. Here's one I always wanted to take. It's an easy one to take. It's the Virgo cluster. It's called Markarian's chain. And it's a series of galaxies. All these fuzzy objects represent billions of stars in each one, because each one's a separate galaxy. And they happen to form a chain, and there's more down here and more down here. When I carefully counted them before I cropped it here, I had over 30 galaxies in that photo. And I really like that photo. And it's color, even though it looks black and white. The other thing I want to mention is there's 3 galaxies interacting gravitationally, and that's the Milky Way, Triangulum, and Andromeda. And Andromeda is huge, and it's heading right for us. So don't make plans for a few million years from now. It's going to collide. What happened? I went backwards. There we go. Um, that's what you get if you take some of these dim objects with a full moon. No matter what you do, you can't bring out the North American Nebula in that photo. And here's my best, or I call it my best, my favorite photo, and I took it right from here. This is the Flame and Horsehead Nebula. And remember I showed you the belt of Orion? That's the first star in the belt, the one furthest to the left. And you could now see even clearer the emission nebula that lights up the dark nebula, the Horse's Head, right there. There's your blue. This nebula is blue because it's reflecting the blue star right here. And then look at all the detail you can get in another emission nebula. Part of this is dark, part is an emission nebula. And I want to point out one interesting thing about this photo. Look at the top half of it compared to the bottom half. What do you notice? There's a lot more stars, right? Look at all the stars here and so few stars here. And I'm going to tell you why that is. The reason is because all this is a dark nebula. So only the brightest stars are able to shine through, and there's no nebula or gas cloud here, so you see all the stars. And so all this is a dark nebula, just like the Horse's Head sticking out of it. And that's the Flame and Horsehead Nebula. So the bottom line is, the more photons you collect, the better your pictures are going to be. And because photons make up the signal to noise ratio, and there's no other way to get more photons except aperture, how big an opening you use, how big your telescope is, and exposure time. And you know how to calculate it now from that 500 formula. And the more photons you collect, the better your astrophotos. Maybe that should have said the more photos you stack, the better your astrophotos are. Because remember, you're always stacking. Now I'll just show you some random photos that I took. This is one of my favorites. It's called the Leo triplet. The constellation Leo has 3 galaxies close together, and this is called the Hamburger Galaxy. And look at the detail in this one, M66 and M65. And what I did, because everything's digital these days, you can blow things up, and look at the details you can get if you blow up that one M66. You can see some blue, some luminosity, but you also see noise. And that's the problem. You need a bigger telescope not to get the noise. An unusual one, looks like a rose. It's called the Rosetta Nebula. It's also not far from Orion. And this one is nice because it has a cluster of stars in the center. And most of these are bluish stars, which means they were formed from the gas cloud. And there's M101, the Pinwheel Galaxy. Remember, 25 million light years away. And I like this one because I got a little color in the center. This was shot over 3 nights. And the other thing I want to point out here, besides the color of the different stars, is you see a little reddish object here and here. Those are nebulae in another galaxy. The red is other nebulae. So you can get tremendous detail even with a small telescope. And finally, for astrophotographers, it may not look like much, but it's the Iris Nebula. It's a tough one to photograph. The reason is because it's got a couple of bright stars in the center, some nice color, but the petals of the iris are here and they're dark. So you have to be careful not to get too much noise. But I like this photo personally. And there's many other galaxies you could take. These are the more common ones. One of these is called the Cigar Galaxy, for obvious reasons. The other one is Bode's galaxies, M82 and M81. And it's nice when you can get enough photons to get some color in these. Otherwise, if you look through some of the telescopes, you just see black and white. And this is a work in progress, M78, the Casper. It's just an unusual large, and that's really all I have to say, except I was surprised myself how much I liked astrophotography, because I looked at I got involved with astronomy a little bit over the years, but I really liked the challenge of being able to get a photo of something that's dim and 25 million light years away. It's a thrill. And starting here, there's a lot of good astrophotographers here. I'm a beginner in a lot of ways, and they were able to help me. And the internet and YouTube has a tremendous amount of information, and that's where I learned a lot of the techniques, along with talking with people here. So I've been a member here for 2 years. The other thing is you really get to appreciate and see the details of these objects. Looking through a telescope, I never had that detail that I was looking for. And a telescope and long exposures, you have to get good at it, gives you those details, as I hope you've seen. And I do love the technical challenge, making the hardware and software work. And I never knew much about software, but it's not that hard. Dedicated amateur astronomers write software that you can download. And it's worth the long nights in the dark fighting the elements. And finally, the big reason, I want to impress my family and friends. Thank you.
All right. Thank you, Mike. I'm just going to.
You want the last slide?
If you want to, you can put that up, yes. Right. So I want to thank everyone who has joined us here in person. I also want to thank our online chat for bearing with us. We have had some technical difficulties with our live stream, so I just wanted to thank them for hanging in there with us. So we are going to be doing a question and answer session. I know there was definitely one question here in our live audience, and we'll get to that shortly. However, I did notice a couple people had joined us in the middle of the presentation and did not get our safety briefing. So quick overview for those of you who are here. If you do need the restroom, that is to the porta potty to my right, your left. We do have a little gift shop and museum area through the door into the house to my left and your right. Each of those little sheds you see has a roll-off roof and houses its own telescope and equipment. If it has the roof rolled off, chances are there's a volunteer inside willing to show you what they can see through their telescope. Some may have EAA, which is electronically assisted astronomy, which uses a camera, much like astrophotography, attached instead of an eyepiece to the telescope.
I can add to that. What electronically assisted astrophotography does is, instead of an eyepiece, you have a computer and you take short exposures that are automatically updated on the screen so you can see the object in near real time. You just don't get all the details of deep space astrophotography. Thank
Yep.
you.
But chances are we also have a number of scopes with eyepieces. We just ask if you are not feeling well, refrain from possibly touching it because we like to keep our people healthy and coming back. When you do go to leave, as you notice, it's gotten a bit dark. We are going to use our headlights. Please use the headlights. As much as we love our night vision, we love not being run over more. Uh, so we would like to avoid that. That being said, if you do have a flashlight, because we understand you might have trouble getting around, please do keep that pointed towards the ground because we don't want to unnecessarily blind people otherwise. So, we're going to get into the question and answer session. And since I know we had a question out in our audience, we're going to take that first. I believe you had the question about the one telescope.
Well, thank you. Yes, I was looking online, looking at telescopes. I bought a telescope, but it was
I'm
very
sorry, I can't hear.
okay. I bought a telescope. It was inexpensive just to try it out, to get a feel
Right.
of it. So then I said, well, you know what? Maybe I'll buy something better now that I got a feel of it. And I was looking online, and there was a telescope called Stellina. It seemed like a new technology where one would not have to stack. I think it stacks it automatically. It stacks everything automatically and does everything. So I was just wondering if anyone used it or knew about it, and what did they think about it? That
Well,
was about
it sounds like it's the electronically assisted astronomy because, like I said before, it does stack everything, and it lets you see it near real time.
Yep. So, Mike, I'm going to have you hop back on there because otherwise our online audience can't see you. So, we do have also a couple of online questions. The first question was, what is your favorite astrophotography target?
My favorite,
Yes.
it's really tough, but I would have to say the first one I ever took is my favorite, and that's Andromeda. And the reason is it's big, you get a lot of details, it's 2.5 million light years away, and you can't see it that way any other way except by taking a photo of it. So I would say Andromeda is number one, and the Great Orion Nebula is number two.
Right. Was there a question from our live audience? Perfect.
Why do you use two cameras, one on the guiding scope and then your regular camera?
Okay, good question. Um, the the main camera is called your imaging camera, and that's on your big telescope. And if I have a setup in the back, so anybody that's interested, you can take a look. And that takes the photographs themselves. While it's taking the photographs, the guide scope and camera is monitoring a separate star. So you have to have a second camera to monitor the star. And as soon as that star moves a little bit, it sends a signal to the mount to correct it. And those corrections are so minute that you don't see them. And the imaging camera continues to do that 5-minute imaging. So they serve totally different purposes, and you have to have two. I hope that answers your question.
Right. So our next online question was, could you use film for astrophotography?
Wow, that's a good question. I used to use film. I used to develop film. Uh, and the short answer is you could use it for an object like the moon, very bright objects. When you have dim objects and you're exposing something for a long time, I don't know how film would behave. You also have limited ISO capability with film. In other words, the film speed is limited. with modern digital cameras, you can go up to thousands of ISO values, which you could never do with film. So I think it's very limited.
I would imagine for that you might have better luck taking the digital images and actually printing them on. It used to be like you were well you would remember because you grew up with that tech and
Well,
I did too. The clear transparency film you
yeah.
used to use on the overhead projectors.
If somebody's really interested in film, what some photographers do is they take a digital image and they scan it into a high resolution scanner, and then they get a digital image like you would with a digital camera, and that they can print, they can manipulate. So that's another way.
Yeah, like I said, trying to turn that into a negative and
Yes.
printing it on like that transparency
Good point.
film.
Good point.
That being said, if someone wants to experiment, I'm sure that would be a lovely topic of discussion on the Discord channel. Was there another question with our live audience? Yep. Thank you for waving your hand. Keep your hand up because I lose you in the dark.
I just want to know if we can take our own exposure pictures tonight.
I'm sorry, I couldn't hear that.
If we could take our, can we take our own pictures tonight?
So he wants to know if he would be able to take his own long exposure picture.
If
Unfortunately, most of the equipment here that has astrophotography equipment is owned and operated by someone. If you had your own equipment and had it set up, I would say you could probably do that, but that would be up to the owner and or operator of the camera whether they would be willing to work with you for that, because we are a volunteer organization. So
thank you. Yes, right there, right
Oh.
behind you.
hold on.
Do you ever shoot infrared?
Did I ever shoot infrared? No, I haven't. Infrared requires a different. It needs a. The best infrared needs a modification to your camera to convert it to infrared, and it gives you dramatic effects on leaves, and it's a different format. By the way, I did change my digital SLRs. I had them modified to make them properly sensitive in the hydrogen alpha region, the 650 nanometers, because digital cameras off the shelf have a filter over the sensor, and it blocks some of the infrared light. When you take nebulae, you want that red infrared light to come in, and so my camera is modified.
Right. I'm just putting out a last call for anyone online who can hear this. If you have any last minute questions, if you want to get them in, and I'm just saying that now because there is a slight delay between when I say it and when they actually hear it. So another online question was, what southern target is your favorite, or is at the top of your photography wish list?
Uh,
So I
my
would imagine if
I
you were
s-
ever vacationing in the southern hemisphere.
in the southern, I'm not experienced with the southern hemisphere, but of course some of the constellations are the same, and so some of the nebulae will be the same, some of the star clusters will be the same, except they'll look upside down in the southern hemisphere. For the summer targets, is that the other question? A nice summer target that's relatively easy to shoot up here is the North American Nebula and the Pelican Nebula. That's coming up right now, and it's very high up in the sky, so it's a real nice target. You're not going to see it looking up. You have to find it and then do a long exposure. It's a dim object.
All right. Was there another question from our audience here? Anyone? Anyone? I'm just going to check YouTube because that did get slightly disconnected from my chat program. And I just want to make sure we get in all the questions. All right. looks like we got all of our online questions. And since we've seemed to have exhausted the questions here, excuse me, I want to just thank everyone again for coming
you.
out, and thank everyone online for putting up with the technical difficulties. We will have our recorded copy uploaded so you can better view the program tonight online if you were in our online audience. So thank you very much and have a good night.